Hello, this is Tim Mitchell with Wolfhound, and I have a new project for today. My new project is a 20-watt LED fixture. Most of the work has been done on this already, all the mechanical work. I'm using a base plate from an old lighting fixture. A lighting fixture that very much looked like this when it was in the beginning. So this is a base from a lighting fixture, and then I have, this is like a microphone base for a mic stand. This is a mic stand very similar to this. This is a black one, but this is the very same shape. Of course, you don't want black when you're working with lighting fixtures, so you want a silver color, so that you get a nice reflection. I like to get the LEDs very far apart when I'm putting it together, so that the shadows aren't very strong. If you use a single bright LED as your as the light illuminator, you end up with a very stark shadow. It's distracting, and it's not very pretty. It never gets good. It's sharp outlines. It's really not a great light. So I like to get the lights very apart enough that a single shadow is not created, and it's a better illumination. It's better light. And also there are some heat sinks. I added some heat sinks onto this. LEDs under normal operation get rather hot, and 20 watts of LEDs get very hot, as a matter of fact. So I want to make sure I can get as much radiation from this, so that I can get the natural air cooling, so that I don't have to use a fan to cool it. The bell of the mic stand and the base of this lighting fixture both work very well to dissipate the heat. So these 20 watts, these 5 watts each of LEDs, these 20 watts of LEDs will produce a large amount of heat, and this should be sufficient to dissipate all of that heat. For the most part, these extra pedals, the heatsink pedals on here, are directly under the LED, so that you get maximum radiation from that. The LED terminals need to be bent. In the beginning, when you get the LED is designed as a surface mount. And there's a heatsink on the back, and 2 terminals on the side, and then the illumination comes from the lens on the top. Initially, the terminals fit flat to a surface, and this won't work for the kind of projects I'm making, so I have to bend these terminals up like little wings, so that I can solder to them later. I'll take some needle nose pliers and bend these terminals out so that they're like little wings. They end up little wings, and so that when they sit on a surface, I can easily solder to them. I can solder to that very easy with the wings on there. So very important. I mount these down with glue. In this case, this is a regular ordinary 5-minute epoxy, a Gorilla Glue. In this case, it's actually this glue here, Gorilla Glue, and I glue these down with great pressure, so that the heat sinks come in contact with the bell of this microphone stand, so that heat is transferred. Since heat is such a big problem with LEDs, that's one of the biggest problems, as a matter of fact, so you need to deal with the heat. So they're glued down with pressure so that they get good heat transfer, so that it gets good radiation. The glue isn't necessarily good for heat, so you need to have good heat radiation, so that the LED doesn't actually melt the glue that's holding it down. The glue that I used for the other parts of the fixture, which also needed a heat transfer on the fins, on the extra fins, and the microphone stand to the base of the fixture is using a steel reinforced epoxy, and I'm hoping that the steel will help transfer the heat in the material. So this is just the start. This is just the mechanical part of it. It's been about 3 weeks now, and I've actually finished it. These 20 watt LED light I had started almost a month ago. It's using a series parallel connection. The power comes in on one side through 2 LEDs, crosses over to the other side, is parallel to those 2 LEDs, and then back out, making a series parallel connection, just like this one right here. Pretty much exactly the same thing through the buck converter. The buck converter controls the current and makes sure that it's controlled for the LEDs. In this case, these are 5 watt LEDs. Each LED is 5 watts. And the tech doc says that these 5 watt LEDs are 700 milliamps at somewhere close to 7 volts. Now the voltage varies with temperature, so you have to drive them with current. So since these are 700 milliwatts each, the tech doc says 700 milliwatts each, it'll be 700 times 2, since they're in parallel, 2 in parallel, 700, and then so 2 times 700 is 1.4 amps, and then that's seriesed through one wire, and then you got the other 2, so it also stays 1.4 amps, but since it's series parallel connection, the voltage goes higher. So instead of running around 7 volts like for one pair, it's closer to 13 or 14 volts for the 2 pair together. For this arrangement here is should be around 1.4 amps. The power for this is provided by a 15 volt wall wart transformer. 15 volt, it's 2 amps, 2.5 amps, 15 volts, 2.5 amps, and the wire is just a splice from the power transformer into the wire that goes to the fixture, which is close to 10 feet long. When I originally built this, I said that I pretty much thought I had all the heat handling problems taken care of, but this thing got way too hot. It's too hot to touch. Even on the top surface, it was too hot to touch. And so I was kind of dismayed, so I decided to add this fan onto it. I thought it was going to work without the fan, but I got the fan. I got it off of this was a very small CPU cooler that I had mounted an LED to. And so I took the fan off of this CPU cooler and put it right onto right here. The fan needs 12 volts. And the LED needs 1.4 amps. After I got this running for the first time, I discovered that the buck converter putting out 1.4 amps is actually putting out about 12.5 volts to the LED. So it's 12.5 volts. So while that would work, it changes every time the LED heats up or cools down. It changes its voltage. So I can't really run the fan off of what's coming off of here. So I have to branch off to another buck converter. This one is not concerned with current. It's just concerned with taking this 15 volts coming in from the wall wart transformer and making 12 volts for this fan. And this is a little bitty buck converter too. It's regulating the voltage. And it's not much bigger. It's really of the same size as an LM317, which is a linear voltage regulator, but much less efficient. So using one of these little mini buck converters to power the fan, and using a current controlled buck converter. This potentiometer here controls the current for it. So let me turn it on. It still gets pretty hot. Okay, I have the camera set to manual to lock the exposure. So I'm gonna actually put it up high a little bit here. So what's overhead is four fluorescent lighting tubes. They're 4 feet long. It's should be about 160 watts of fluorescent light overhead, and it actually pulls about 200 watts from the wall. So this is this lighting fixture here, and the overhead lighting fixture is off. So that's the comparison. It's got about a 25-degree beam, maybe 35 degrees coming out of it. It shoots light up all the way out 180 degrees from the fixture, but its much brightest point is at about 35 degrees out from the fixture, which is about 5 feet over this table that it's on. So just as a comparison, I'm going to turn this light off and turn the overhead fluorescents back on. And so that's what the fluorescents were doing. And then back to the LED fixture. Right here. And I'm just got it wedged up under a thing full of connectors. If you don't mind things falling. Anyway, yeah, you can actually see the mess in here. The color of these is supposed to be natural white, or somewhere around 4K. And it's the most pleasant color that I've used from the company that I buy them from. So that's it. I don't know what I'm going to do with it. It's really not bright enough to use in over my workbench here. So I was thinking about using it as a video light, or maybe an area light in the house. I'm not quite sure. But it's finished and it's working, and now I'm going to take it and use it. Another point I wanted to make was about the arrangement of 4 LEDs instead of, say, using 1 LED in the fixture. And I was talking about making the shadows much easier to take. So this fixture is the only fixture on, and I have my hand over this paper right here, and let me just sweeten it up a little bit, and you can see that it's not just a single shadow, it's more of 4 shadows. And as I get my finger or whatever object closer to the paper all the way down to it, it becomes a very sharp, distinct shadow. But the idea is it softens up the shadows. It's not a very sharp, to me, obnoxious, harsh looking shadow. It actually could use a diffuser over this to even soften it up even some more, because even this is a little bit hard to take. So that was, I guess that'll finish this up for until the next project. So keep watching, and you accidentally subscribe or like it or something, okay? So see you guys on the next project. Thanks.